So we have a problem on the board here, another word problem. This is the second one I did a word problem the other day. And the question asks, Melissa drives to the beach 15 miles away at 60 miles per hour. Later, she drives to the post office 3 miles away. Melissa's average speed for the whole trip was 54 miles per hour. What was her average speed for the drive to the post office? And what I'm going to do, I have on the board the general equation that we use for a problem like this, rate times time equals distance. But in this case, we actually have a few different things going on. We have the first trip, which I'm going to write out, and this is going to be for the trip to the beach. So we'll subscript that with 1 for the trip to the beach. And then the trip to the post office. And then finally, what I'm going to do, what we're really trying to look at is the full trip. So let's going to just rewrite this up here. For the full trip, I'm just going to use capital letters. We're going to say the big R is going to be the rate of the whole trip. Big T will be the time of the whole trip, and big D will be the total distance. Okay, so first, let's just focus on the trip to the beach. So we know the beach is 15 miles away. So we can put in for that distance, we can put in 15 there. And we know the rate to the beach is 60 miles an hour. And we don't know time 1. But what I'll do while I'm over here, I'm going to just solve for that because we have our other 2 variables. So T1 is going to be 15 divided by 60, just dividing by 60 on both sides. And that's a quarter of an hour. And that's actually the same thing as 15 minutes if we were to convert it to minutes. Okay, so that's all the information we can get out of the trip to the beach. Then for the post office, we don't really have enough, but we have the post office is 3 miles away. But we don't know the rate to the post office and we don't know the time to the post office. Okay. And then let's see what other information we have. Melissa's average speed for the whole trip was 54 miles per hour. And that one's going to go right here. So we know the R. Let's come down here. So we know R is going to be 54 for the full trip. Her average speed was 54 miles per hour. We don't know anything about time. They don't give us any time. But can we find the total distance? And we actually can because we have the distance to the beach. We have the distance to the post office, and we just have to add those together. Okay, so D1 plus D2 is going to be 18. And so then, coming down here, if we put this, we want to look at our RT equals D. This is for the whole trip now. We have 54 miles per hour. T we don't know, and the distance is 18. But now we have we only have one unknown in our equation, so we can solve for that. And that's going to be T equals 18 over 54. And that's just going to be 1/3 of an hour, which is the same thing as 20 minutes. Okay, so we have a lot of information. We know everything basically about the beach. We know everything about the round trip, but we still have some unknowns in the post office. And then the question is, what was her average speed for the drive to the post office? Okay, wait, so we know we got this because we know T1 and we know our big T. What I'm gonna do now, be careful here, because what I'm gonna do is I'm switching over to minutes, which can be very confusing. I just like to it's kind of nicer in this kind of problem to work with the minutes rather than fractions of an hour. So you can do that just as long as you're consistent and you make sure you're being careful with it. So we know, okay, so our big T, our total time is going to be T1 plus T2. And see, we know that the full time is 20 minutes. We know T1 is 15 minutes. We don't know T2, but what we can do is just subtract 15 on both sides, and we find that T2 equals 5. And now we've actually solved everything except for the rate, because we actually know we have our 5 here. So all that we know is we need to know the speed, average speed for the drive to the post office. And so coming back here, we have R2 times 5, and this is minutes. So, I really should go back to the fraction here. Otherwise, this is kind of the trap I was thinking of. If I just worked with minutes and then I switched over, it wouldn't make sense. So in the context of this, where R is in hours, miles per hour, and this is in miles, I need T2 to be in hours. So it's going to be 5 over 60. And then we have this, and then what I can do is just multiply 6 over 5, which is actually, I can just multiply through by 60 over 5. That cancels. And this is going to be running out of space, but this is going to be 36. This 60 over 5 reduced to 12. 12 times 3 is 36. And so that should be our final answer. We solve for each variable, and we have the rate to the no, sorry, the speed. The post office is 36 miles per hour. It kind of makes sense because, well, it does make sense because if you look at the first trip was going 60, and the second trip to the post office is 36, those average together to 54. Kind of logically makes sense. So let's check the answer here. And that's correct. Hopefully you found that helpful, and I will stop it there. Thank you.